Hi everyone, Assalamualaikum. In this video, we will discuss second fundamental theorem of calculus. Now we look at the theorem. F prime x equals to d over dx. Integrate from a to gx. A is constant. Okay. Ft dt equals to f gx times g prime x. Okay. Alright, for instance, we can use f prime x equals to f gx times g prime x. So we can write this, okay? F prime x equals to this one, right? Alright, gx means here, okay? Upper limit, okay? Fgx means we can refer from ft, okay? We replace t by gx, okay, over here, right? So this is the theorem under second fundamental theorem of calculus, alright? Now we look at example 1 from previous semester papers. Let fx equals to integrate from 0 to cert 2 minus x, and then in bracket cert 3 plus t squared over 2t dt. Use the second fundamental theorem of calculus to find number Roman 1, f prime x, and number Roman 2, f prime x. Okay. Alright. First, we solve number Roman 1, f prime x. Okay. To find f prime x, we jump to step here. Okay. F prime x equals to f gx times g prime x. So first, we need to find gx and g prime x, okay, in step 1, right? And after that, we need to find fgx, okay? And to find fgx, we need to find ft, okay? Then we can find fgx, okay? Alright, how to find gx, okay? Right, from the theorem, f prime x equals to d over dx, integrate from constant a dx, ft dt equals to f gx times g prime x, okay, from this theorem. Then we just compare. Our gx equals to upper limit, okay, means our gx equals to cert 2 minus x. So we can write under step 1 here. Okay, gx equals to cert 2 minus x. Then we need to find g prime, means we need to differentiate. And to differentiate cert function, first we change to bracket to the power of half. Okay? And then when we have bracket to the power of any value, we can differentiate using generalized power rule. Okay, so we get g prime x equals to, we move power to the front and then copy in bracket and then power minus 1. Okay, that's why we get half and then 2 minus x and then to the power of negative half, and then don't forget to multiply by, we differentiate the function inside bracket. So we get 0 minus 1. That's why we have negative 1 here. Okay, times negative 1. Okay. Alright, then we simplify, so we get g prime x equals to 1 over 2, and we have negative here, so negative 1 over 2, and then we move down bracket to the power of negative half, so we get bracket to the power of positive half, or square root of 2 minus x, right? Then we continue with step 2, okay? We need to find ft, okay? So, how to find ft, okay? From here, okay, from the theorem here, we just compare, okay. So ft means in variable t, so we have ft equals to cert 3 plus t squared over 2t, okay. Then from ft, we need to find fgx to substitute into this formula, okay. Alright, fgx equals to f square root of 2 minus x, okay. Why we get this? Because we just replace our gx okay, equals to 2 third x. Okay, we replace here. Okay, I mean third 2 minus x. Okay, our gx. And then we compare with ft here. Okay, if ft, so we get t here. So if now we have f third 2 minus x, all variable t here we replace by third 2 minus x. Okay. After that we can simplify square root here and square here. So no more square root and square here. Okay. Then we simplify 3 plus 2 equals to 5, and then minus 1 inside square root symbol here. Alright, over 2 and then square root of 2 minus x. Alright, after that we can use this formula. Okay, under step 3, f prime x equals to f gx times g prime x. Okay, so our f prime x equals to, we replace f gx, okay, by third 5 minus x over 2 third 2 minus x. Okay, and then we replace g prime x equals to negative 1 over 2 times third 2 minus 2x. So we replace here. In between must minus. I mean in between must multiplication here. Okay, from formula. Okay. And then we simplify, so we get positive times negative. So negative third 5 minus x over 2 times 2, 4. And then we have third and then squared. Okay. Then we can simplify squared and third here. So we get negative third pi minus x over 4 times 2 minus x. Or we can expand denominator here. Okay. So this is the final answer. F prime x equals to negative square root of 5 minus x over 4 times 2 minus x. Right? This is the answer for f prime x. Alright, now we continue with question Roman 2. Find f prime 1. Okay. From the previous slide, we find number Roman 1, f prime x equals to negative square root of 5 minus x over 4 times 2 minus x. Okay. Now we just replace x by 1. Okay, into variable x. So after we simplify, so we get negative and then square root of 4 over 4. Okay, and then negative 2 over 4 and equals to negative 1 over 2. Okay, this is the answer for f prime 1. Right? Coming up next, more examples for second fundamental theorem of calculus. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.